Hey everybody, we are working on this assignment, special segments of similar triangles. It's kind of a hybrid. We did some proofs in class and proofs in the other video. We got some definitions here. And then I just wanted to have you do a few practice problems, basically just applying those, the theorems that we proved. So they're not designed to be very hard. I just want you to think about the things that you proved and how you can use that to solve problems, basically. Okay, so on this guy, you're going to do these problems 5, 6, 21, 22, and 25 from pages 319 and 321. If you run out of room, you're welcome to do it on a different page. I just thought for you it might be convenient to do it all on the same page to help you scan less stuff. But do it as needed, or use this extra space as needed. So I've made a copy of this. This is coming from the textbook, so don't write in your textbook. I'm going to write directly on this because this is just a piece of paper that I copied, but I'm going to help you set these guys up. Okay, so the two problems we're doing from this page are 5 and 6. And hopefully what you'll notice here is that we have triangles with a median. So these are going to be two similar triangles. And we got this guy being a median. Okay, now what we just proved in theorem 6.8 is that the ratio of the medians of similar triangles is the same as the ratio of the corresponding sides. So that's what we're going to want to do, is we're going to use that fact to set up a proportion. So the ratio of these corresponding sides would be 6.5. Sorry, is that 6.5? I think it is. 6.5 over 13. Copy didn't come out good. Equals x over 12, right? Numbers are going to cross multiply. This actually reduces to 1 over 2, so I think I'm going to do that first. Cross multiply 2x equals 12, so x equals 6. Okay. All right, now in number 6, you got medians. So they're not altitudes, they're medians, but the same kind of thing applies. We're just going to set up a proportion. Now you may be wondering how I knew the triangles were similar. It actually doesn't say that they are, but here we got angle, angle, right? Which means that these two small triangles are going to be similar because all we need is angle, angle to get similar triangles. But also, if this is a right angle, then so is this. And basically we get, the other triangle is going to have to be similar as well, also by angle, angle. So the same is true here. You'll notice that they marked a couple angles congruent for you so that you can know that the triangles are similar. So the proportion here that we want to set up would be something like 20 over x equals 16 over 12, or x over 20 equals 12 over 16, or something like that. A little bit of flexibility in how you set these up, as long as you're consistent in the direction that you're setting them up. Okay, so something like that. Now 16 over 12 reduces to 4 over 3, so that's an option. And then you're going to go ahead and cross multiply. So I don't want to take all the fun out of it for you, but that's the setup, so you can kind of take it from there. All right, on the back side, we got 21, 22, and 25. Okay, so again, here we have altitudes. We have similar triangles, so there's the statement saying the triangles are similar. So we're going to set up a proportion. Now in this particular problem, we end up with a quadratic equation, which I wanted to kind of go over with you because, it's been a while since we've solved those. We actually did it earlier this week, but before that, it's been a while. So my proportion here is going to look like this. X over 2, the ratio of the altitudes, is equal to 4 over 6 minus x, the ratio of the corresponding sides. So when you cross multiply, you get 8 equals 6x minus x squared. Remember, you're going to distribute here. So it's x times 6 and x times negative x. All right, now be careful here because this negative x squared, can throw you off in a big way. So what we're going to do here is we're going to add x squared to both sides. Now these are not like terms, so we got x squared plus 8 equals 6x. Okay. Remember, if we want to solve a quadratic, the technique that we have right now, there's other techniques, but the one that we're using right now is factoring. So we want to set it equal to 0. And again, no like terms here. So I have x squared minus 6x plus 8 equals 0. Okay. So what we want to do here, now that we've set it equal to 0, is to factor. And we can use the x method here. We're looking for factors of 8 that combine to give you negative 6. So two things that multiply and give me a positive number, but when I combine them I get a negative. That must mean they're both negative. If it was positive, that could give me a positive 8, but I would never get a negative 6 from that. And if it was positive, then they would multiply to be a negative 8. So I'm thinking it's negative 4 and 2. So something like that. Okay, and then we're going to set each factor equal to 0. So the zero product property says if I multiply two things and the product is 0, then either the first factor is equal to 0 or the second factor is equal to 0. So add 4 to both sides, x equals 4. Okay, add 2 to both sides, x equals 2. Now the question itself asks us to find the measure of DC. So it's either 6 minus 2 or it's 6 minus 4, which is a little confusing because you're like, well, how do I have, it makes sense to have two x's as a solution to the quadratic, but how does it make sense to have two different side lengths for the same side? Well, let's take a look here. If we put in x is 4, then I guess those are the same. I guess that kind of makes sense. I guess there's a couple different options here. I was thinking, we could narrow one of them down based on the side lengths, but if we put in 4 here, we get 6 minus 4, that's 2. Now, of course, this looks a little bit longer than this one, but again, sometimes we can't trust the scale. If we put in 4 here, we got 4 and 4, which means those are the same. So that's, again, the scale's kind of throwing us off. I guess we can check the ratios, maybe, and see if that will work. I think we're going to have two different answers here, and that's maybe okay. But if I plug, let's see, if I plug 4 back in, then the ratio here is 4 to 4, which is 1. Okay, then that's got to be the same over here. So if I plug 4 in here, I get 6 minus 4, and that's 2 and 2, so that works. If I plug a 2 in here instead, then the ratio is 4 to 2, or 2 to 1. If I plug a 2 in here, I get 6 minus 2, which is 4, and the ratio is 4 to 2 also. I guess they both work. So yeah, we're going to go with that. Either one will work there. Okay, let's take a look at 22. Okay, in this case, we have medians. So we got, we're going to basically we're going to set up the proportions here. This guy over this guy equals this guy over this guy. Okay, so 12 over 32 equals x minus 5 over 2x minus 3. Okay, that's the setup there. I'm going to let you solve that. This doesn't come out quadratic. It comes out linear, so you should be okay there. And then this guy, again, we have medians. So x over 8 equals 9 over 2x. Okay, now this one's going to be quadratic. So let's do this one. Cross multiply, we get 2x squared equals 72. Okay. Now this one we could actually factor if we wanted to, but also we can do this with just inverse operations. It's not hard to isolate x, so I would probably divide both sides by 2. That gives you x squared equals 36. Take the square root of both sides, and you get x equals plus or minus 6. Okay, now in this case, if you plug in a negative 6, that doesn't make sense for a length. So I'm going to go with x equals 6 in this case. Okay, so you get a quadratic, but it's one that we already know how to solve. You can just solve this by taking square roots. Now let's just say, for the sake of argument, that you wanted to solve it with factoring. Okay, it's still doable. So first set it equal to 0. Okay, next factor it. Well, this is not a trinomial, it's a binomial, and so we can factor out a common factor. And then this is a difference of squares. Sorry, writing faster than I'm moving my paper. So now we have either 2 equals 0, which is not the case, or x plus 6 equals 0, or x minus 6 equals 0. So the zero product property, if 3 things this time are multiplied to 0, either the first thing is equal to 0, which it's not, the second thing is equal to 0, or the third thing is equal to 0. So minus 6 on both sides, x equals negative 6, add 6 on both sides, x equals positive 6. So plus or minus 6, positive or negative 6. But again, we talked about how the negative doesn't make sense for a length. So we're going to go with 6. All right, so I did 3 out of the 5, excuse me. You get to do the rest of them, finish the rest of them, okay? Now remember that the goal here is understanding. So if you're using the video to help you, that's great. Oh, that's what it's for. But there's a difference between help and like becoming a crutch. And the difference is, are you learning or are you not learning? So if you're using the videos to just copy down stuff so that you can turn in your homework so you can get points, you're not really doing it right, which means you're probably going to not do super well on the next test. So if you didn't know how to do one and you watch the video, great. Take a blank piece of paper, cover up the problem you just did, and do it again and make sure you know how to do it. And do it enough times that you got it down and you're confident that you could do it on like a test or quiz. All right, thanks for watching, guys.